Now, in algebra, one of the most important skills that you'll need to have is to be able to do something that we call recognizing like terms. And then later on, to be able to simplify those terms in expressions and in equations. So let's take a look at the example that I have on the board. What I'm going to do here is I'm going to explain how something from real life translates into an algebraic expression and how we can recognize like terms. So in this case, I've drawn a very inadequate basket of oranges and bananas, and I've written the number that we've got here. So we've got 3 oranges and 2 bananas. To write that as an algebraic expression, I might use the variables O and say we have 3O for oranges and 2B for bananas. So what I've got here is an algebraic expression. We know that because it has some numbers and some letters or some unknowns, in this case variables. And we've signified that this is a binomial expression because it's got an addition in between the 2 terms. Now these 2 terms are what we would consider unlike terms. The same is true in real life. We can't put these 2 terms together because they're not alike. We call them unlike terms. Just like we would never say, in this basket, we've got a total of 5 Banoranges. Banoranges don't exist. The same is true in the algebra world. I can't put O's and B's together because they're not the same. So I can't do anything with this expression further as far as simplifying is concerned. Okay? The same is true if I've got an expression that looks like this. I've got 4x squared minus 2x. Now both of these have numbers, letters, and some kind of operation in here. I've also got a binomial expression. But in this particular case, I'm using the same variable. But if you'll notice on this particular expression, this exponent and the exponent that actually is here, which would actually be a 1, is not the same. So these are actually unlike terms as well. So in this case, I've got unlike terms, and in this case here, I've also got unlike terms. So the rule is, in order for them to be like terms, they have to have the same exponent, and they have to be the same variable, and they have to be to the same exponent. So for example, if I've got something along the 5s, and I've got plus 7s, those would be considered like terms. Notice the variable is the same, and the exponent is also the same. So these would be considered like terms. As well, I could also have something like 5p cubed minus 3p cubed. Notice I've got the same variable and I've got the same exponent, so I would consider these ones to be like terms as well. And in our next video, we're going to see the kinds of operations that we can do with like terms when it comes to simplifying them. So in this video, I've showed you what like terms are.